All righty, let's do problems 2 through 66 even. We'll call this lesson 46 or 47. I'm not sure which. I'll have to look at the channel and see where we're at. And go through these fairly quickly, I hope. And then the second half of the test will take us from 68 to, I don't know, 116, something like that. All right, so minus 2i to the 35 is all about I squared, which is -1, an odd number, even number of times. What do we have? 17 gets me to 34 times one more, gets me to 35. And this is an odd exponent on sign changes. So I'm going to get a sign change. So -2 is going to become +2. 2i is your answer there. So we get a sign change because that's odd. All right. Minus 2i to 7i is minus 14i squared, which is the number 14, plus 9 is 23. So you don't have to write this out. You can do this first, and then this. You should be able to do that in your head. Minus 6i from 21i is 15i. Now I'm talking to you, and when I'm talking to you, multitasking, because I'm doing the problem at the same time I'm talking to you, which can cause carelessness. I'm hoping that I don't have a whole lot of it in this video, but I anticipate the possibility, a very distinct possibility, that I'll goof somewhere. All right. Let's just write our answer here. So x, I know my frame of reference is 1 plus minus square root. -6 is going to become an imaginary because I'm dividing by 2. -6 divided by 2 is 3. I believe that takes care of that one. Factoring. Well, first thing you want to do is take out what's common. So that gives me 2 times x squared minus 6x plus 7. Okay, that's a problem. Did I really want to say this? Because there's only one way to get 7, and that's 1 times 7. So I got an issue here. So I'm going to have to change that to a minus, because I don't want to have people talking during the test about this problem. So now it's -7. That's very helpful. So that becomes 2 times x minus 7 times x plus 1. And you got a little putting sums and differences into product practice. Then there's something called factoring. That's what that means. All right, so let's get an eraser here. Let's tackle this. So I got to remember to make that change. I hope I do. Plugging in a 0. I can't believe I gave that. Plug in a 0 must have been when x. Was it f of x equals 0? I can't imagine I would have said plug in a 0. All right, you got to give me 4/5. If that's what I said, it's what I said. All right, so let's change this. Let's multiply this one by 8 and this one by 5. That'll give me 40, -40, and that'll cancel the y's. So 8 times that. Can I take the shortcut and say just 8 times 4x and 8 times -6? Can I do that? Can I do 5 times this? 5 times this is going to get me 5 times 5x. And 5 times 8 is +40, and 8 times -5. Hope you can see why I'm taking a little shortcut here. And equals 21. So now we have 32x equals -48. And we have 25x equals 105. And so that's going to be 57, I believe. 57x is equal to, take 140 away from 100. Well, that's 52, 57, so this is 57. Oh, that's so nice. All right, so x is 1. That solves our problem. And so I might as well do it here. 5 plus what equals 21? I think I need 16, and I'm multiplying by 8. I think my y value is 2. You take more time with it. It's your practice, not mine. I see a binomial square. I see 5x plus 3. Yep, that's 15. Doubled is 30. That was just a recognition problem. You pause the video before each of these problems, I hope. All right, so we're just going to write our answer here. I know I'm going to square the x and multiply by -4. So on the answer key, I do that. I know I'm going to double this. So that's minus 8x. Minus 8x times minus 4 is 32x. I'm just going to write it. I know that gets squared. It's 16. I know that's a cubic. So that's minus 64 plus 3 is minus 61. Now you can write it out if you want. You can do the 3 minus 4 times this. If you're happy doing that, go ahead. But if you want to improve your performance, I strongly suggest you memorize. That's x squared. That's minus 8x. That's 16. I think you can see it from here. And that's 16 times negative 4 is minus 64 plus 3. I mean, I think you can do that kind of work. Push yourself to, at least when you're practicing. If you got time, yeah, write it out. Make sure. It's a test. Make sure you're right. F of x, that's the input. We'll call this x1. x1 is the input, and this is x2. x2 is solving. 3 raised to the x1 minus 2 is equal to x2. And we want to get a function where the output is the input of the inverse operation. So where do you get inverse operations from? Solving. So what's the inverse of 3 to the? Log base 3 of. Okay, and that's really still x2. Okay, that's our x. And then minus 2 becomes positive 2. And how do you check something like this? Well, let's get a number for x1. How about we plug a 3 in? 3 minus 2 is 1. 3 to the 1 is 3. If a 3 doesn't get me a 3 over here, I got a problem. And let's put a 3 in. Oh, that's 1. That's the exponent I put on top of 3, right? I'm looking for the exponent on top of 3 that gives me 3 to the 1. I think it's 1. And 1 plus 2 is 3. So that answer was correct. So let me just write it. Now everybody knows log base 3 of x plus 2 is the inverse of this. Okay, graphing form. All right, well, I know I got a positive 5 and I know I got a subtraction. And now all I got to do is b over 2a. So 20 divided by 10 is 2. So that should be right. So minus b, positive 20 over 2 times 5 gets me 2. And I want it to act like 0 squared because that's going to be the minimum area. And 2 is going to make that happen. And if I drop in a 2, minus 40 can be cut in half, plus 15. If you're not seeing that shortcut, then keep putting 2 in. Go ahead. 2 squared, 4, 20 minus 40 plus 15. Oh yeah, 20 minus 40 is half of that. All right, so what do we get? Minus 5. Okay, can I see all of that? Can you see all of that? I guess so. Kind of hiding that work. All right, so what is graphing form? Let me just make sure at the end of the term. So we have a x minus h squared plus k. All right, next problem. Been asked many times, but what I'm really looking for is the following. 9x squared plus 1 times 9x squared minus 1. Great if you wrote that, but that tells me you haven't figured out yet how to spot the difference of two squares. Any subtraction can be written as a product. And so I'm really looking to see if you factor 9x squared minus 1. Because if you didn't, you haven't digested this yet. So 9x squared plus 1 times 3x plus 1 times 3x minus 1 is what I hope to see. Oh, the inverse of this. Can't be that question because that's the one I just did. All right, moving along. There are different ways to do this. One of your answers is 0 immediately. So you could get rid of one of the x's by dividing out an x. But you have to remember that 0 is an answer. I don't like dividing by negatives, so I'm going to move 7x squared to this side. Then I'm going to factor out the x, 7x plus 1. So what are my answers? My answers are 0 and negative 1/7. mx plus b form. Let me erase this. You pause the video, go ahead and do it. See if you get the same answer. Do it mental math. mx plus b form minus 5/3 times x Now I've got 20 over 3 minus 3 over 3 is 17 over 3. Okay, so minus 5 times minus 4 is positive 20 over 3. I'm subtracting 1, so I'm going to change that to 3 over 3 and write that. Okay, let's get rid of that. Pythagoras, well, what you're supposed to see here, you're supposed to see that that is 49. That is 25. And that is x squared, which is 24. So therefore, that's the square root of 24. All right, so now I can fill in the picture, square root of 24. So what is the tangent? In this case, it's negative. Okay, good thing I looked. I'm in the second quadrant, so it's negative. So my answer is minus 5 over root 24. And I don't care if you simplify that or rationalize it. I'm testing to see if your Pythagorean theorem is in place. Your definition of using the reference angle, this is more than 90 degrees, using that reference angle for opposite over adjacent. I like to say height over width. But if you did this and said 2 root 6, I'm happy still. And if you move the root 6 into the numerator and call this 12, that's fine too. I'd almost rather see you leave it minus 5 over root 24, so I know you've done this work. Come on, get out of my way, Chair. Sorry, Renee. We'll have to see if Geico is going to pay for that. A little difficult. Well, we're going to go with it. All right. So I got a function that's going down. And if I move the 2, it's really going down to 2 to 3. So it's really more like that. All right. And I want perpendicular. So the answer is embedded in this. It's 3, 2, x minus. I don't know what I asked you to put it through. We'll say AB. All right. So now A gets you B. Okay. So that's embedded there. But if you did it out, constants don't affect the rate of change here. So it's the interplay of these two. And we can see that the original is down 2 over 3, which is what I kind of drew here. Down 2 over 3. The perpendicular is going in the other direction, over 2 and up 3. And I hope that that looks okay in terms of the perpendicular. 0, 0, you certainly don't have to write x minus 0 squared plus 0. Right? I'm hoping you just write x squared. And if you square a 2, you get 4. If you don't want the 4, get rid of it and put in a 3. There's your rise over run squared as measured from the vertex. I hope that means more to you at the end of the semester than it did at the beginning. All right, so that's that one. Writing a product, might as well do the numbers first. So I've got 3 situations, 20 and 16 have 4 in common. I need 3 places, so I'll do that. Write this here. I need 5 for that one, another couple of places, and a minus 4 for that one. That should work. Y cubed, y to the 6th, y cubed. I don't need it for the first, but I need another 3 for the second. Z and z squared. Take the z out of this one. I don't need it there anymore, but I need another one here. And maybe that is going to avoid some carelessness. Yeah, I'm hoping that, you look at this and you say, piece of cake. Cube root of 8 is 2. So I got 2 to the negative 4, which is 1 over 16. We should be at that stage. I need an x minus 3 to get the first 2 terms. Minus 3 times minus 3 is positive 9. How do I get to 11? I add 2. And I hope you can see the cancellation here on the last multiplication. I hope that's all obvious to you. If you really want to make sure you're right, then f of 3 should get us the remainder of 2. 9 minus 18 plus 11. 9 minus 18 minus 9 plus 11. There's my positive 2. All right, equation of line tangent to y. Well, we need the slope formula, which is double that number because x squared changes according to 2x. We've been drawing those pictures for weeks. It's the layering process. So my slopes come from 4x plus 5. I drop the number 3 in, y prime at 3 is equal to 17. That means I'm going up at 17 to 1. I have a cup-shaped graph. And minus 5/4 is that x value, and I'm moving to 3, so I'm over here somewhere. And that equation is 17x minus 3. It'd be nice if I knew the y value. Oh, I have a way of finding the y value at 3. 18 plus 15. 18 plus 15, I believe, is 33. Hope I'm not making any careless math errors. And so that's this tangent. Let me draw it a little differently so I can show you a tangent. Let's say it's there. All right, then that would be that equation. We have a location, let's say a time, a location, and a velocity. All right, what are the roots? Well, if A is 2, well, first off, I'm measuring from 5. That's my frame of reference. I got to go 2 different directions in order to hit a height of 0. Height of 0 is that x value. Height of 0 is that x value. 1 is to the right, 1 is to the left of 5. Okay, how far do I have to go from -11 to 0? 11 units. Of course, I'm multiplying by 2, so I better divide that by 2. And of course, I'm squaring that, so I better hit it with a square root and remember the plus minus. All right, now, if you didn't follow that, you got the graphing form here. 2x minus 5 squared minus 11, and we want to know when that's 0. I hope you can see all of the inverse operations in this answer. Point of inflection, local max. You've got the rate, I gave you the rate, and you have the point of inflection, then you have everything at your fingertips. Except I didn't give the A value. I forgot what the A value was on the test. And I have to tell you that too. So A, we'll say A is 3. I really don't know what A is right now. But I do know the point of inflection is going to measure from this X value. For the same reason that this discussion took place over here. All right, so X, I'm measuring from 1. I know it's a cup shape up with a negative rate. So therefore, I know it looks like that. And I'm looking for that X value, and I know this one starts at 1. Okay, so I'm going to move backwards to get to that local max, excuse me. And it's an interplay of the rates. I gave you this rate, so it's when this rate, it's when the cubic rate is going up at 7 to 1. And we've got that, again, all those inverse operations and finding that. So that's the X value of the local max. Yeah. Local max formula, one more time, H plus or minus, that gets the min in this case. The square root of minus m over 3a. I forgot to multiply 3 by 3. That's my mistake. I'm glad I did this. 9. I was in quadratic mode over here, I think. Okay, so this is a cubic, so that should have been a 9. So there was my first, hopefully and only careless error. But that should be your answer. Okay, so apologize for not catching that immediately. But talking to you, I said it was going to happen. All right, we're practicing domain and inequalities is another topic that we use the number line for to help us quickly. I've got a 7, I've got a 2. Can I use numbers bigger than 7? There's going to be a sign change here too. But that's not going to affect this. I'm talking domain. So can I use numbers bigger than 7? Well, that would be a positive, and that would be a positive. And yes, I can. Can I use 7? 7 minus 7, 0. Can I divide by 0? I don't think so. That's the discussion we've been having in class. I need a number bigger than or equal to 2. So 2 works, and this is bigger, yes. But I don't think I can put a 1 or a -1,000,000 or anything like that in here. That's a no. So what intervals work? Well, 2, that should be a bracket. 7 doesn't work, but everything from 7 on to infinity does. That's your domain. If I don't pick these numbers from this interval, if I pick anything other than numbers from this interval, and I'm working with a calculator or a computer, it's going to say no solution. Or can't work, whatever, undefined. I don't know. I haven't worked with a calculator in so many years. I don't know. All right, so this one was, God, what did I ask? Well, let's do all 3 things. Let's go the shape, V shape down, -6 is where it hinges. We'll just leave that for now. So therefore, as a piecewise function, I'm going up on the left, which is a positive slope. And then it hinges at -6. So that's only going up for x is less than -6. Those are the numbers I have to pick if I want to be on the upswing. Down after -6. And I got to include -6 on one of them. It doesn't matter which one. I usually use the bottom, but it could have been there just as easily. Now, maybe I asked to solve this equation for something. I don't know. All right, so let's pick an odd number. How about -11? When does this thing equal -11? All right, so I'm going to erase this now. No, I can do it here. I'll do it over here. So I'm going to subtract 5. I'm going to divide by -2. And now I'm going to be 8 units to the right and the left of -6. So that's telling me this. Which means that this intersection right there, that intersection is at x equals 2. We'll check it in a minute. And then this one over here is at -14. So let's put -14 in, add 6, and we've got -8. As a value of -8, 8. 8 times -2 is -16, plus 5 is -11. All right, now let's say we want to be greater than, let's be less than -11. Less than -11 is all of these x's here that go with these locations. All those x's. Well, where are they? They're certainly not there, because that's the one, those are the ones that get me things bigger than -11. So it looks to me like I'm going to -infinity to -14, union 2 to infinity. I just wanted to write the -11 there. All right, we're getting there. We're getting there. Yeah, you can do these in your head. That's great. Well, all right, so the purpose of this is to get the intercepts. So the y-intercept, or the x-intercept's 25. What do we got? 15, excuse me. So 15, and I know I'm coming down, so I'll put the 15, comma 0 here, because I know that that one is 25, so that's a little higher. There, 0 gets me 25, and there's your graph. That's what you're supposed to know how to do for something written in standard form. You're working with the intercepts. All right, so hopefully you might look at this and you can write the answer quickly and easily. What's your frame of reference for 11 pi over 6? My brain went there to 12 pi over 6. Then my brain said 30-degree reference angle. Well, there's my -1/2. And if you're coming in to look at this and you haven't done the preliminary work to grasp that, you want to look at Introduction to the Unit Circle. Intro to the Unit Circle. And you also want to watch the video, What is a Radian? If you haven't seen those, and you're struggling with that at all, then you gotta do a little work. What is a radian? All right, so that takes care of that. So now we're going to try to do the same thing here. Tangent's a little more difficult to work with, but my reference angle is going to be -12 pi over 3. I wish I had put something in a different place, but I've got the same reference, and I'm going around in the other direction, and I want -11. So I'm going to erase this and do a drawing. So 11 pi over 3. Pi over 3 is a 60-degree angle. There's 60 degrees. So there's our half. There's our √3 over 2, our 0.87, and there's our 1. Right? Actually, that's where I am. I am right there. 60-degree angle because I'm going 1 less. Right? This is breaking up into 6 parts. 3 in the top half, pi divided by 3. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 right there. Drop the perpendicular, and you've got that triangle. I like to double the size of that triangle. I like to work with this triangle where I double everything. That's a 1. That's a √3, and that's a 2. Okay, I can see my tangent clearly now is √3 over 1. So I think I'll just write equal to √3. And I've asked you to memorize that decimal. Be interesting to see how many, if I gave a test just on the memorization of what I asked you to memorize. That was an interesting statement. 1.73. That's what I've been using for the square root of 3. Close enough. All right, minus 29 pi over 4. See if you can picture where you are. Multiples of 4 should come into your head right now. Okay, I got mine. So I think this is going to be root 2 over 2. Let's see if I'm wrong. We'll find out. So I went to 20. I think I'm already wrong. So 28 pi over 3, 7 pi. Yeah. So 28 pi over 4. Excuse me, I said the wrong thing, getting close to the end here. Is 7 pi. That's my frame of reference. So I should have been a little bit further, right? And that would have been here. There's my 45 degree, and my width is negative. So initially, negative root 2 over 2. Initially, I had myself memorizing over here again for some reason, probably because we just did a couple like that. All right, but that one should be negative root 2 over 2. Okay. Rate at point of inflection. Well, you got to find the point of inflection first. Okay, because we're going to use, do we need it? C3A, yeah, h squared. So we need this formula. H is minus b over 3a. That's the horizontal movement of the x value of the point of inflection. So minus b, positive 12 over 6 is 2. So now we have this number is 2. The a is given, that's also 2. And c is given, that's 5. So if you memorize the formula, and you know minus b over 3a, the average of the roots, is the reshaping of a cube to be a perfect cube. That's where it comes from. Then you're ready to answer the question. So I'm looking at minus 24, 5 minus 24, negative 19. I know an awful lot now. I know the x value of the point of inflection. I know the rate of change. I know the values of the x values of the local max and min. Don't have to do any work for that. I know the rate of change at the tangent to the y-intercept. I think I can graph an awful lot of this. The only thing I haven't found is the y value at the point of inflection. And I think if you put 2 in there, you've got that too. All right, so in class the other day, we worked very hard on graphing these quickly and easily. All right, so what's the base? I'll ask this in kind of a different order. What's the base of this logarithm? Well, it's all about those differentials. From 3 to 5 is 2 units. And from 3 to 11 is 8 units. I got a base for it. And what's going to get me, the reader, to see that my numbers have to be bigger than 3 in this calculation? The domain, bigger than 3. A statement like x minus 3. And what happens when I use the number 5? I get log base 4 of 2, which I do know the answer to, but a lot of times you won't know the answer when you plug that first x in. So what you do is you put 5 minus 3 is 2 and divide by 2, and you get log 1. I don't care what the base is. You make this any base, bases have to be positive, but that's 0. 0 is very nice to multiply by. It's really nice to multiply something times 0. Right now I am. And if I want 1903, I don't care what you multiply. Just write 1903. But if you use 11, 11 minus 3 is 8, and 8 divided by 2. Oh, yes, that is the base. Because if I have 1903 plus some multiplication of log base 4 of, when I put 11 in, 4, well, I think I can get pretty easily to 2000 because I know that number is 1. And I got to get to 2000. I think I'm going up 97. Okay, that's what that was. Next problem. Rather than give you the tedious process of giving you an x, a z, and a y value and making you go through it and find the others, just want to make sure you know how to read that. And that means y varies jointly as x and inversely as z. I'll take that. Or I'll take y equals y varies proportionately, right, directly as X, Y varies directly as X and inversely as Z. So I want to see this written on your answer key. So this is the ln of 40. Okay, 2 cubed is 8 times 5. So let's look at the exponents that come from the number 40. Let's do it above here. I got to put it in E notation. Well, the first thing I'm going to do is write 8 times 5. Okay, 8 is 2 cubed. We have memorized the values of 2 in E notation, e to the 0.7. Let's get this out of the way. 5, e to the 1.6. Okay, so what am I doing? I'm doing 3 times 0.7, so I'm doing e raised to the 3 times 0.7 plus 1.6, which is the same thing as saying e to the 3 ln of 2 plus the ln of 5. I got those off the calculator, those approximations. And log base e is what ln means. So what is the exponent I put on top of e to get what's in the parentheses? Well, I got the e's. Those seem to be inverse operations. I guess this is the exponential activity. Where did it come from? Where did we start this discussion? The ln of 40 brought us to that. So we're going backwards. Okay, so this 3, we could have positioned it there. We could have positioned it there. And what's the exponential activity? Well, it's got to be in terms of e. So that's got to be e to the 0.7, so on and so forth. I'm butchering it now, but that came from this. All right, so this is a duplicate. And I will change this for the next test to some other question. But right now, if you get it, you get another point. It's my fault, not yours. So 4x minus 12 assigned slope. Wonder what I get if I put a 0 in for x. A slope of minus 12. Huh. Wow, that just shows up. Okay. I guess that's the equation of the tangent line at the y-intercept. Oh, I digress. So at x equals, what did I say on the test? Who knows? No idea. How about I say x equals 5 for right now? All right, so the slope at 5 is 8, 20 minus 12. So I have a slope of 8, and I know 5 is the x value. That gets me what? Let's plug it in and find out. 25, 50, minus 60, plus 7, minus 10 plus 7 gets me minus 3. That's the equation of the tangent line to this curve. And this is 12 divided by 4 starts at 3. So your tangent line is right about there. And that's the equation of that line is the equation of that tangent. All right, so I'll take a breather here and then I'll do the second half of the test for you. And I'll upload this later today. Why am I telling you that? I have no idea.